Okay. Algebra 1, Trooper Tie Tuesday, in this case, Trooper 1 Tuesday. Discuss tests we did that SVBA. Students will be able to solve equations by addition and subtraction, section 2.2. Mr. Costle, I'm in section 2.1. I didn't like section 2.1.x. Okay, start in section 2.2. Okay, life hacking. Okay, it's called batching. Okay, anyway, let's go from the office. Solving equations by using addition and subtraction. Pro tip, write your name up here, okay? Solve using addition. Suppose my Algebra 1 class has 25 students. Suppose my Algebra 1 class has 25 students. And my Algebra 2 class, I should change that to geometry. I don't teach Algebra 2 right now. My Algebra 2 class has 25 students, okay? Is 25 and 25, are those the same?
Yes.
Okay? So suppose I have the same number of students in these classes. They both have 25. If each class adds 2 new students, the number of students in my classes would still be equal. Is that true?
Yeah.
Okay, let's think about that. So if I take 25 plus 2, what am I also doing to this right side of the equation? We have a left side of the equation and a right side of the equation. I'm still adding 2, right? Because I'm adding 2 to each class, right? So how many do I have in my Algebra 1 class?
27.
And how many do I have in my second class? 27. So it's still equal, right? Would they still be equal if I added 2 students to one class but 3 to the other?
No.
No, why not?
Because one will be higher.
One will be higher than the other. So do I have to add the same thing to both classes for them to be equal? I would have to add the same thing to both classes equal. So this example illustrates the addition property of equality. I almost missed that little blank. This represents the addition property of equality. We have this nice little box here, this little chart, that says, hey, addition property of equality. In words, it means if an equation is true, so 25 equals 25, that's true, we said, and the same number is added to each side, add 2, the resulting equation is true. 27 does equal 27, right? Okay, so we just demonstrated that. If you have a true equation already, you add the same thing to both sides, you still have a true equation. Okay, so as for symbols, for any numbers A, B, and C, if A equals B, then A plus C would equal B plus what? If A equals B, we add C to one side, B plus what would equal that? Zach? B plus C. We have the same thing to both sides. Okay? So it's like saying A plus 2 is equal to B plus 2. They're already equal. In a number example, if we start out with 5 equals 5. Start out with 5 equals 5. And let's say I add 1 to the left side. What do I also have to do to the right side to keep it equal? Add 1. We can think of it as kind of a balance beam there, okay? We have to add the same thing, otherwise it'll get too heavy on one side, or the equation is balanced right now. Okay, and then 5 plus 1 is?
6.
6, and on the right side, 5 plus 1 is? 6. Oh, still 6, it didn't change. Okay. Okay, so does everyone know what I mean when I say the left side and the right side? Okay, so I'm talking about where the equal sign is. So left side is just to the left of the equal sign, right side is to the right of the equal sign. So whenever I say up the side of the equation, I'm talking about side of the equal sign there. I want to clarify that. Okay? So in these blanks here, we have that equivalent equations have the same solution. Equivalent equations have the same solution. Now to solve an equation, we say that means to find all values of the variable, that make the equation a true statement. So when we solve an equation, we're saying that's when this equation is a true statement, is when the variable equals this number. We do this by isolating the variable, which means getting it on one side by itself with the coefficient of 1. Getting it on one side by itself with the coefficient of 1. Has anyone heard the word isolate before, or isolating? What's that mean? Presley? Yeah, taking something by itself. When's like an example that you guys have heard that maybe?
When you're,
Good.
like, if you do something, like, people in the power were isolated.
Okay, people in the powder room are isolated, right? They're away from the general student population, less and less raised on half, less we get. They're more by themselves. Okay, Dylan?
Like, if you're, like, if you're not around people and you live in the woods or something, you're isolated.
Okay, if you live in the woods, okay, you're isolated from society. Okay, that'd be true. Okay, so when you say isolating the variable, we're trying to get it by itself. We're trying to get it alone with only a coefficient of 1. Remember, coefficient's a number multiplying with a variable. Okay, in football, if you're familiar with football, okay, there's a run play called the ISO. That comes from isolating because you isolate a player on the defensive side, and you choose not to block them. Okay, you're isolating that player. You're creating a one-on-one with that player. See, football does apply to math. Math applies to football too.
Have you played football?
What?
Have you played football?
I played for a couple years in high school, but not every year. No, I love football though. Love it. Mm-hmm. We laid the smackdown on Sunday over those Atlanta Falcons. Just a smack down, okay? What? What did you say?
I like Packers.
Gross.
No,
No pack, no.
Vikings.
When I went trick or treating this year,
Like the Vikings.
Levi was wearing his Viking jersey, and then I was wearing
Levi.
my
Chiefs.
jersey.
Well, Chiefs.
You mean your Green Bay?
Like
I like the
Packers.
Vikings.
Levi, you're a Vikings fan?
Yeah.
I knew I liked you for a reason.
I like you too. You like
I don't like you.
Okay, what jersey do you have?
I had the Adrian Peterson jersey, but I need to get it updated.
Get it updated? What is
Yeah,
it?
Adrian
He's
Peterson
not on the
plays for
team
Vikings.
anymore.
I have an Adrian. Okay, solve each equation, check your solution. R minus 8 equals 32.
I
Too
do
much
R
energy,
minus 8
too much
equals
energy.
32. R minus 8 equals 32. What's our variable here?
Can you start talking like a stormtrooper?
No.
How do they talk?
Okay, what's our variable here?
R.
R. What's happening with R? We're subtracting 8. Okay, we're subtracting 8. So we need to think of how do we undo that to isolate? We're trying to isolate, so how do we get rid of that subtraction of 8? Ray, how do we undo that?
Make the R a 40. We're
Okay.
gonna add 8 to both sides.
We're going to add 8 to both sides. What we're going to say here is we can say, I can add 8 to this side, but we know from our addition property of equality that to keep the equation true, we're saying the equation is true already, to keep the equation true, guys, thank you. To keep the equation true, we have to add it to what side as well? If we add it to the left side, we have to add it to the right side, we have to add it to both sides, okay? Now hey, can we combine R and 8? Can those combine? Are they like terms? No, we just learned last chapter they're not, okay? R is a variable, 8's not a variable, okay? But what is negative 8 plus 8? 0, okay? That's what we call the additive inverse. Whoa, it's coming back, okay? The additive inverse. So it ends up being 0. So we really get R plus 0 is equal to, what's 32 plus 8? 40, okay? Now hey, if we're saying plus 0, do we really even have to write that plus 0? No, and in the future we won't write that, okay? I just wanted to show you guys that right now. In the future we won't write that. We'll just say R is equal to 40. We'll say R is equal to 40. So we solve the equation. We got our variable by itself, okay? And when we say a coefficient of 1, if we don't see a number in front of this R, what number is really there being multiplied with it?
1.
A 1, because if you multiply anything by 1, do you get a different number? Do you get the different or a same number?
Same.
The same number, because it's our multiplicative identity, okay? That's coming back too. Hey, now what's it say in the instructions? Solve each equation, check your solution. Now we're going to check our solution. How do we check our solution? We take our R equals 40, and we plug it into our original equation and see if it holds true. So I take in 40, and I put it in place of R. And I have minus 8 equals 32. And we see it, is this true, okay? Now when I check my solution, I like to put a question mark above the equal sign because I'm saying, is it equal? I'm testing to see if it is. I'm checking, okay? So I got to figure out, is this equal? Okay, you guys know when you guys ask a question, our voice goes up as an inflection usually, right? Like, yeah, is it? Okay, duh. without even thinking about it. Our voice kind of goes up at the end a lot of times when we ask a question, just naturally in the English language. Okay. So I say like, where are you guys going? Like I'll raise my voice a little bit at the end in pitch. And we call that an inflection. Okay. So I can say 40 minus 8 equals 32. Okay. I like to make a joke about that. Okay. So what is 40 minus 8? 32. So does 32 equal 32? Yeah, so I like to put a little check mark. Yep, I checked it and it worked out. Checked it, it worked out. Okay, so we did have the right answer. And I love this about algebra. I love this about algebra. It's one of my favorite things about algebra, okay? I get excited about it, as you guys can tell. Do we know instantly that we got the right answer?
Yes.
Yeah, we do, because we just checked it and it worked. Okay? We would have known if we got the wrong answer. I love that, because that's so helpful on a test. That's so helpful on a test. You know right away whether or not you did it correctly if you check. You know right away. I love that. Nectaria.
Why does this feel like we've done it before? Like we
You
did it
may have
last
started this in 8th grade. Okay? You may have started this in 8th grade. Okay. Any questions on the first one? Okay, let's go on to the second. H minus 12 equals negative 27. What's our variable here? H is our variable here, okay? We're trying to get H by itself. What's currently happening with H? It's being what? Subtracted by 12, okay? So how do we undo subtraction? What's the opposite of subtraction?
Plus.
Addition. So we're going to add 12. Now, hey, wait. Here we chose 8. Why are we choosing 12 here?
Because it's in front of the equal sign.
Because that's the number that we're subtracting by. That's the number we're subtracting by. Thank you so much, Mrs. Morgan. Okay, that's the number we're subtracting by. Okay? Because when we add 12 to both sides, remember I have to do it to both sides, okay? And I want to clarify something, guys. Am I going to do something like this? Where I add 12 to negative 12 and I add 12 to H? Would I do that?
Now
No.
one side of the equal.
Because I have to do it to both sides of the equal sign. Like right now, I'm adding one side by 24, and I'm adding the other side by nothing. That's not going to keep it balanced. That's not going to keep the equation true. It's keep it balanced. I'm adding it to both sides there, okay? So the left side and the right side, okay? Okay, what is negative 12 plus 12? 0, okay? So what I do is I cross that out because they end up going to 0, okay? We don't have that anymore in our new line. They undo each other. They undo each other. It's the additive inverse, so it goes to 0. So now we have H. We still have this H. Do we have to write plus 0? No, we just said we didn't. We could if we wanted. We don't have to. Now we write the equal sign. We just keep writing what's there. Negative 27 plus 12. They're different signs. They're different signs. So you subtract 27 minus 12 is 15. But which number is bigger, 27 or 12? 27. So it is negative. You take that sign. Then we get H equals negative 15 because H is now by itself. Yes, Levi. Okay. So we just look at, if we cover up the signs, which one's bigger? The positive is bigger than the negative. That's true. That's true. That's a good point. Okay. Now, how would we check our solution again?
By doing it.
Plug it in. Very good. So we'll take this negative 15 and rewrite our first equation with plugging it in. Negative 15 minus 12 equals, okay, negative 27, okay? Hey, so negative 15 minus 12. Two negatives there. We have a negative and a negative. So we're going to add those numbers together. What's 12 plus 15? 27. Okay, but now we take the same sign that we had. So it's a negative 27. Does negative 27 equal negative 27? Yeah, last I checked. Write a little check there. We checked it. It worked. So we know we got the right answer. If this was a test, we would know we have that problem correct. And that's awesome. Guaranteed points. And if it doesn't work, well, we know we can go back and we need to fix something, okay? Let's write down that plus we forget.
Bless you.
Okay? I want you guys to try number 3 on your own. Now, I had to clarify, is this saying 3.5?
No, it's 3.
No, it's this question 3, and it says 5 equals x minus 10. I want you guys to try solving number 3 on your own, okay? And when you're done or you have questions, I want you to raise your hand, okay? When you're done or have questions, I want you to raise your hand.
When we're done, raise our hand.
Yep, or if you have questions.
How about for
Let's look at the red example. Oh. Let's try that. Great question. Why is my flag back there so crooked? So it's crooked because of the way, just the way that it is. Need your more video. No, it's crooked because I have like the right side hung up in the ceiling, like between the tiles and the metal, just by friction there. But on the left side, it's hung up by a hook, because I can't hang out the right side by a hook very well. So that's just how I had to hang that the right side up. So it's just how I had to hang it. Same question.
That is so
Good
weird.
luck, America.
What is that flag?
The colonial flag from the 13 colonies.
Oh,
Okay, let's talk about this one up here. Okay, so this time, x is on the right side of the equation. Does that change what we do though? No, okay. Oh, I would. Okay, so what's happening with x? It's being subtracted by 10. So we say, what's the opposite of subtraction is to add. We're trying to undo this subtraction. We're trying to get rid of it. We're trying to isolate the variable. We're trying to undo what's happening. Right, Zach? Right, Zach? Okay, I was about to eat a pen at you, okay?
Sorry, I'm like gone right now.
I like gone right now. It's processing it.
Oh no.
Oh, yeah. Okay. Man, okay, so I had on a shirt underneath. I have a shirt underneath this, okay, because otherwise, like, I'll look at anyone, okay. So, and I had a shirt on, like, this morning that was the Kool-Aid Man saying, oh, yeah. Well, like, you can kind of see it, like, oh, I'll change this to plain white shirt. But now I wish I would have worn it, because that would have been a perfect opportunity to be like, oh, yeah. Man, how funny would that have been? Anyway, so we add 10 to this side. What do we also have to do to the left side of the equation? Add 10. Okay, what is 5 plus 10? We'll just go left to right. What's 5 plus 10? 15 equal x. Negative 10 plus 10. 0. Do we have to write it then? No. 15 equals x. How do we go back and check our solution? But 15 is x. We rewrite this equation the exact same, but now 15 is x. So we say 5 equals, instead of x, we have 15 minus 10. And I always substitute in parentheses just because I think it makes it easier for our negatives, okay? So anyway, and I put this little question mark saying equals, okay? So we know the left side we're saying the same. There's nothing happening there. 5. What's 15 minus 10?
5.
5. Does 5 equal 5?
Yeah.
Yeah, so I'm going to put a little check.
Yes,
It works.
sir.
Okay, yes, sirree, right, Hannah? Yes, okay. Any questions on that one? Okay, Gucci, okay. Okay, so when isolating the variable, getting by itself, it doesn't matter if the variable's on the left side or the right side. Okay, we have the variable on the left side, or on the right. Okay? For example, see number 3 above. Did it matter whether the variable is on either side? We said no, it didn't. Okay? So don't let that freak you out. Either way, we're trying to get the variable by itself. That's our goal. The variable by itself. Questions on that? Okay, right Right below this, it says, hey, now we're going to solve using subtraction, okay? We're going to solve using subtraction. So similar to the addition property of equality, we're saying if we have a true equation, we add the same thing to both sides, it's still true. We have the subtraction property of equality, we can use it to solve equations. So this is saying, if an equation is true, and the same number is subtracted from each side, the resulting equation is still true. So in symbols, for any numbers a, b, and c, if a equals b, then a minus c will equal b minus c. So we're saying if a equals b, if any number equals a number, and then we subtract the same thing from both sides c, it's still true. So in numbers, an example, if we have 4, does 4 equal 4? Yeah, okay, that's a true equation. That's a true equation. So we started off, if an equation is true, we started with a true equation here, okay? Now, if the same number is subtracted from each side, so let's say I take 4 minus, let's go with 3. That will equal 4 minus what number?
3.
3. I have to choose the same number, right? Would it work if I choose a different number?
No.
No, okay?
Then it's not equal.
So then it's not equal, okay? What is 4 minus 3?
1.
1. What is 4 minus 3? Oh, it's the same, okay? So 1 does equal 1. So if we subtract the same thing from both sides, we end up with a true equation, okay? Now, if I subtracted 3 from this side, and I got 1, if I didn't subtract anything from this side, would 1 equal 4? No, okay? What I'm talking about there, don't write this down, 4 equals 4. Let's say I subtract 3 from the left side, but I don't want to do it from the right side. Let's say I only want to do it to one side. Well, 4 minus 3 is 1. Does 1 equal 4?
No.
Heck no. That's why we have to subtract from both sides to keep it equal. Just like how we had to add to both sides. Okay? Questions on that? Hank, Dope, and Liddy. Okay? Eat, cash money, fire. Okay. Solve each equation, check your solution. Okay, example 1, k plus 63 equals 92. Okay, it's like somebody just sent you a long text. K plus 63 equals 92, okay? So that's what we can do next time. Instead of just saying k, right, give them a math equation to solve. K plus 63 equals 92. Right? Okay? I always get happy when someone sends me a math equation. Okay? So hey, what's happening with k right now?
We added.
We're adding what to it?
63.
63. How do we undo addition? What's the opposite of addition?
Subtraction.
Subtraction. So we're going to subtract. What are we going to subtract?
63.
63. We don't pick a random number. We pick whatever number is there. Because we want to get it by itself. If we pick any other number, it wouldn't get it by itself. And now Danny said, hey, if we subtract from the left side, we also have to subtract from the right side of the equation, okay? So as we rewrite the next step here, did we do anything with k?
No.
No, it stays the same. Okay, so we write it again. What's positive 63 minus 63?
0.
0. Do we have to write it then?
No.
No. Equal sign, we write the equal sign. 92 minus 63. We might not know off the top of our head, okay? Let's borrow, okay? So 2 minus 3, well, we got to borrow. 9 becomes 8. 2 becomes 12. 12 minus 3 is 9. 8 minus 6 is 2. So hey, k is 29. I heard that. Yes. So
Why
k
did you
does
do it
anything-
exactly the same way?
What?
You guys did the row the exact same way.
Nope.
Wait, who did the row?
I did.
Zach.
Mr. Cossel and Zach.
That was okay.
Dude, I am good at it because TikTok, you already know.
I'm good at it. I guess TikTok's pretty Mr. Cosmos video.
Missed.
Oh, cool. Okay, we're gonna do better next time. So hey, check our solution. How do we check our solution?
But you read art.
That does look like an R.
What? That's like an R.
Your
It's a cursive
Oh, my
K.
K?
Looks like an R.
That's a K there.
Is that a cursive K?
No, that's just how I write my lowercase K's, okay?
Really?
Back off! That's how I write my K.
What?
That is not what
That is a
Oh,
K.
I've written my K's like that since I was a little kid.
That's an
Yeah.
R.
That's
That's
an
a
R.
long
Holy-
tail.
Wait, put it in EY.
Look.
R. Oh my gosh. No, not that one.
Ray.
The other one. The other one.
Another one.
That's
That's-
Ray.
That
No,
looks
no,
like
do
key.
it.
R.
That looks like
Y.
Ray.
That's not key, that's Ray.
Yeah.
That's key.
People write K's like that sometimes.
No one
I've
does
never
Y'all are making me feel weird about my K. We're moving on, okay? So plug it in.
Why you guys gotta pull it in?
Yeah, for real, guys. Come
What do you
on.
mean?
Let's try it out.
Ainsley?
29 plus 63 equals 92, okay? 29 plus 63, hey, spoilers, that will be 92. 92 does equal itself. Check, it worked. Okay, I want you guys to try number 2 by itself. Hey, reminder here, okay? Reminder here. Is this 2.7?
No.
Yeah.
No! Let's try it again. Is this 2.7?
Yes!
No! No! Let's try it again. Is this 2.7?
No!
Try again. Is this 2.7?
No!
No. Okay, that's just 7. I want you guys to do number 2 by yourself.
Really?
And when you're done, raise your hand, or if you have questions, raise your hand. Do number 2 by yourself. When you're done with questions, raise that hand. Very good. Check. Okay.
Hey, Bob.
Equals T, but yes.
No, you.
Oh.
Wait, I'm. Wait, what?
Oh.
Wait, no. Oh.
Whoa. I'm so confused. I don't know what 42 right is.
I'm so confused.
See, if you minus 7 from 42, they put a negative there. You man? I'm not doing that.
What?
Hi, Mr. Collins. I want to. Hi, Mr. Collins. I'm Dylan. Oh. That's not funny though, because you actually are Dylan.
Why are you standing right there?
I'm that one.
Dylan, what's your bill?
I'm not saying. Huh? Not sure. I really should. Huh? Doesn't even start with the It doesn't start with the
Oh, yeah, for sure.
I'll give you a hint. It starts with then.
Question.
It's M.
It starts with G. Use it for one.
No, the letters start with two. Meant to be A and E. You trying to figure out my little name? No, it doesn't even.
Bro, when you're done or have questions, raise your hand.
What are you
Is
When
it
you're done or
possible?
have questions, raise your hand.
Oh.
Do you need check?
Ow.
You know Dylan's
You're
funny name?
I don't know if Minecraft backpack.
He could tell you the letter it starts with.
Do you know what letter?
Yeah, I'll.
That was a solid
Yeah,
high
I was-
five. was.
I want a solid high five.
Scott, I did not get permission to do that.
That's bad, thank you.
What did you just say?
Hey,
I think like
I'm done.
I did not give consent to that. Is that clear?
Danny is done.
Danny snatched
my water from me.
Zach, Zach.
The teacher was right there. Why? Chloe.
Zach, you want to go to the picture?
Huh?
You want to go to the picture?
Thank you. Yeah, sure.
Yeah, my phone is red for now.
Yeah, dude, same mistakes.
No.
Do you need check?
Dude, you're not my teacher.
You're not my dad.
Are you actually like supposed to be checking?
Why are
You
you
check me?
my
That's why I checked everyone else.
But it's, I don't watch it.
I don't want you to check like
Zach.
Did you just body
Oh
shake it?
yeah.
Yes, I am.
I'm thinking multiplication.
It's pre-pop. So.
If you get in trouble, you get that. Thank you.
I can check. Maddox, are you gonna check?
Okay. So I think everyone else has been checked, so I still sit there.
You didn't try still?
No, I did. I just remembered.
Let's talk about this. Serenity, what did you do?
I'm stuck.
Hi, I'm
Okay.
stuck on
Wait, do
you.
you
So
need?
what do you do when you're stuck? You sit there on your phone? Oh, okay, so
She said, I'm stuck. You have to shake her hand.
Yeah, right.
I'm stuck. I'm stuck. I am stuck.
What
I'm
did you do?
Mr. Castle. I did.
You subtracted what?
42.
You subtracted 42! Because 42 is being added with t.
Yes.
Yes.
We do it from both sides, okay? 7 minus 42, a good way for us to think about this is saying, hey, if they're different signs, 7 is positive, 42 is negative, we can do 42 minus 7. But wait, Mr. Cross, won't that mess up the signs? Not if we go back and check it, okay? Subtracting. Borrow 1 from a 4, make it a 3, make this 2 and 12, okay? 12 minus 7 is 5, 3 minus this nothing, 0 is 3. Now we have a 35. Now hey, what number was bigger, 42 or 7?
43.
42 is bigger than 7, so we take the negative, we take that sign. Equals. What's 42 minus itself?
You just
Zero.
wanted Papa.
0. And now we're just left with this t. We're left with this t, okay? So negative 35 equals t, okay? To check our solution, we write the equation again. 7 equals 42 plus t, in this case plus a negative 35, okay? 7 equals, what is 42 plus a negative 35?
It's 7.
It is 7, so 7 equals 7, it checked out. Questions over that?
No.
Okay.
Raise on extra.
There's a top.
Unless we forget.
Thank you.
Oh my
Okay.
gosh, I said right. Is there still
Questions on that?
How dead my hair is.
Okay. Ooh. Okay, let's skip number 3. Let's go on to the next page.
Wait, why are we skipping this one?
What about number 3?
Does number 3 happen to be 39?
Oh.
What's your name?
Cool.
Yeah.
Skip it.
Down Africa.
Oh.
Those words, no.
Alright.
Iceberg.
I had video on.
Okay.
That's gross.
Additional examples!
Woo!
Oh my gosh, no, I keep fractions.
That's too bad. Oh, fraction, what are we gonna do? Why is this meaningless? We're doomed. Fractions. No. We'll do better. We'll learn better about fractions. We'll understand them better, okay? We'll practice, we'll improve, okay? We don't need to be drama queens, okay? So, y plus 4/5 equals 2/3. Let's just think about it. Y is doing what right now? It's adding. How do we undo addition? Subtraction. What are we going to subtract this side by?
4/5.
4/5. Whatever number it's being added by. In this case, that's 4/5. Okay. We don't say, oh, a fraction. We don't discriminate against fractions. That'd be rude. Okay. If I subtract by 4/5 on the left side, what do I have to do to the right?
Do the same thing,
Do
bro.
the same thing. Subtract by 4/5. Okay. Here's how we're going to write this. Y stays Y. What is 4/5 minus itself?
0.
0. So we write the equal sign next. 2/3 minus 4/5. Can we subtract that right away? No, why not?
We need to find
A
Common
common denominator, okay? So here's what we're going to do, class.
Please stop. Thank you.
Yes. Here's what we're going to do now, okay? We're going to write this 2/3 minus 4/5. We're going to write it like this. 2/3 minus 4/5. We'll write it just like that for now, okay? Now, in the next step, we will worry about getting common denominators, okay? So we're going to write it there. We're going to write kind of a gather step, so to speak, okay? We're going to write it like that. And now we're going to look at getting common denominators, okay? So this y is going to stay y. It's already by itself with a coefficient of 1. That's how we want it. Cheyenne,
I know the common denominator.
what is our common denominator going to be?
15.
15, okay? That is the lowest common denominator for 3 and 5, okay? So we say, how do we get this 3 to look like a 15? You change it, Zach.
You times both the sides by 5.
You times the top and the bottom by 5. Hey, quick, does anyone know why we multiply the top and the bottom? Let's think about it, okay? So if we multiply the top and the bottom by 5, multiply the top and the bottom by 5, okay? Let's think about it this way. If it's 5 over 5 and we're multiplying it by, what is 5 divided by 5? What's 5 divided by itself? 1. Any number divided by itself is 1, right? You guys don't have to write this part down. I'm going to read that right now. 5 divided by 5 is 1. Now, hey, if I multiply anything by 1, do we get the same number or different numbers? Same number, okay? So if we multiply this by 5 over 5, we said 5 over 5 is the same thing as 1. So if we multiply by 5 over 5, we're really multiplying by, look at my hands, 1. Notice I put in air quotes. It was changed the way it looks. It's 1, okay? Multiplying by 1. Now, 5 over 5 is just 1. So if we multiply it by 5 over 5, are we changing the actual number? If you multiply by 1, are you changing the number? No, 5 over 5 is 1. If we multiply by 5 over 5, are we changing the number? No, we are not. So that's why we multiply the top and the bottom, because we're not actually changing the number. Okay, we don't want to change the number, we just want to change the way it looks. We just want to change the way it looks. So what is 5 times 2? 10. What is 5 times 3? 15, okay? The minus sign stays a minus sign. How do we get 5 to look like 15? How do we get 5 to look like 15? Diane? Times by 3. Now if we multiply the bottom by 3, what do we do to the top? By 3. Because remember, 3 over 3 is the same as what number? 1. So hey, are we multiplying by, look at my hands, look at my hands, look at my hands. 1. Yeah, we're just changing the way 1 looks. We're making 1 look like 3 over 3 for our convenience. We're still going to keep 4/5 as the same number. We're just going to make it look different. Okay? So what is 4 times 3? 12. What is 5 times 3? 15. That's why we did that. Okay? And hey, if we reduced either of these fractions, would we get back to where we started? 2/3 and 4/5? Yes, you would. Okay? Hey, wait, I ran out of room. Okay, here's a little math trick Mr. Costal does, okay? I'm going to take this, and I'm just moving it up here. I'm just going to rewrite it. Y equals 10 over 15 minus 12 over 15. Did I actually do any new math? No, I rewrote the same equation. What did I do? I just gave myself more room.
Good job.
Okay, anyone following this would say, hey, follow the arrow. Where does it go? Boom, I'm there. Okay? Just gave myself more room to work with. That's a little math trick that I learned this in college. I wish I would have learned that way earlier. Like, this makes so much more
Draw
sense.
an arrow.
To just like restart up at the top when you run out of room. Because I always like got a like real squish on the side and went all over the place. I'm like, oh, I can just restart a whole new line. That makes sense. Okay?
I've been doing that my entire life.
Well, okay, guys, you guys are advanced. Okay?
That's a really good line.
You may not
Does that sound weird?
What?
The line is good.
It's like a very nicely drawn line. It's not super wavy.
Thanks. Okay.
Scribble over
So
it.
y equals 10 over 15 minus 12 over 15. Now that we have common denominators, we subtract the numerators. What's 10 minus 12?
15.
10 minus 12.
2.
What kind of 2? Negative 2, because the 12 is bigger and we're subtracting, okay? And what's this over? Over 15. We leave our denominator the same. When we add and subtract fractions, our denominator stays the same, okay? Just like, think of it this way, okay? I have a pizza, okay? The pizza's an 8, okay? That's a pretty good pizza there. The pizza's an 8, okay? Let's say that I have 1/8 of the pizza, okay? 1/8 of the pizza. I add to it another 2/8 of the pizza. I now have 1 plus 2 is 3/8 of the pizza. I don't have 3/16 of the pizza. I didn't add 8 plus 8. If I have 3/16 of the pizza, that's actually less. I don't have less pizza. I have more pizza. I have 8. I have 3/8 of that pizza, okay? Does that make sense?
Have you ever used
Okay.
Photomath?
Photomath is terrible. Anyway,
No, it's
y equals negative 2 over 15, okay? We can leave our answer as a fraction. I'm okay with that, okay? We leave it as reduced as possible as a fraction. Questions on that one?
That
Okay,
was weird.
good talk. Okay. Okay. Let's look at number 2. Okay. 1 equals x plus 0.356. 1 equals x plus 0.356. Okay. So on this one, what's happening with x?
It is getting added.
Added by what?
0.356.
Ah, decimal! Oh, this is almost as bad as a fraction. What am I gonna do? Okay, we'll be fine. We'll learn. We'll get better.
I like
Okay.
decimals more than fractions.
Okay. So how do we undo addition? We think through the same math process we did here. How do we undo addition?
You
Subtract.
Subtract. What are we gonna subtract by in this case, Zach?
Oh no.
0.356.
Yeah, we're gonna subtract by that 0.356. Now if I do it from the right side, what do I have to do to the left side?
Same thing.
The same thing. Okay? Now, we chose that number very specifically, right? We chose that number very specifically because then we'll get to what number on this right side.
Huh?
It'll give us what number on the right side?
X.
0 and just x by itself on the right side, okay? That's why we chose that. Now, hey, 1 minus a decimal, what do we have to do with that 1? Turn it into a decimal. Where's the decimal point on a number that you don't see?
To the
Behind it, to the right, okay? 1 is the same thing as 1.0. Can I keep adding zeros?
Yeah.
Yes.
Yes. Now if I added like a 1, would that change it?
Yes.
Yeah, but if I add zeros, that doesn't change it, okay? So in this case, how many zeros are we going to want to add? Does anyone know?
3.
3. Why?
Because there's 3 places.
Because there's 3 decimal places on the other fraction, okay? On the other decimal, excuse me.
Why are you back?
Okay? So, voice off, guys. Attention up here real quick, okay? So 1.000 minus 0.356. Hey, wait, 0 minus 6. What do we have to do there?
Borrow. from
Borrow.
1.
But we can't borrow from the 0, we can't borrow from 0, we gotta borrow from this 1. 1 becomes 0. What's this 0 become?
10.
10. What's that 10 become now?
9.
9. What's this 0 become?
Wait, why did
10.
you cross it? Oh, never mind.
Okay, what did this 10 become now?
9.
9. And what's this last 0 become?
10.
10. Woo! We did a lot of borrowing there. Because we had to get all the way over to the right. Now, what is 10 minus 6?
4.
9 minus 5. 9 minus 3. 6. Okay, and this decimal stays the decimal. We keep that in line. What's 9 minus 0? 9 minus 0. 9. So we end up with 9.644 equals x, and we said 0.356 minus itself is 0. We don't have to write it. And that ends up being our answer. Questions on that? Okay. Is subtracting decimals something new to us? No. Maddox, what's your question? Excuse me, how do I get 9? I don't get 9. That was a 0. I just miswrote that. Excuse me.
Yeah.
Thank you for saying something. That's a big oof.
Oh.
You're right.
That was very
Thanks for saying something, okay? I wrote that incorrectly. Let's fix that. I appreciate you saying something. Excuse me, that was a 0. I misread my own writing.
It's okay.
Okay, that's a good catch there. Good catch. I misread my own handwriting. That happens. Okay, good catch there. Thank you. So it is 0.644.
How do you
That makes way
write
more sense. Okay. So anyway, let's go on to number 3 real quick. Let's go on to number 3 real quick. Okay. A plus 1 is equal to 2 over 7. A plus 1 is equal to 2 over 7. Wait, we have a fraction over here. Are we gonna freak out?
Yes.
No.
Ah.
Okay. Go crazy. Ah, go stupid. Ah, go crazy.
That's in my
okay.
TikTok bio, or was. And then I
Okay.
figured it out.
So hey, what's happening with A?
It's being added.
Being added. How are we gonna do that?
We subtract.
We subtract. What are we gonna subtract by?
1.
1. What are we gonna subtract from this side by? 1. We keep it equal. What's A is still A. What's 1 minus 1?
0.
0. We get rid of it. Equal sign is equal sign. Okay. Hey, wait. 2/7 minus 1. Let's just rewrite that because we can't do that yet. Okay. How can we're gonna have to get common denominators? Denominator. I don't see anything beneath the 1. What's secretly beneath the 1? A 1. Because 1 divided by 1 is 1. Anything divided by 1 is the same number, okay? So hey, what's going to be our common denominator here? 7, okay? So 7. How do I get this 1 to look like a 7?
Multiply by 7.
Multiply by 7 on the top and the bottom. Because what's 7 divided by 7? 7 divided by 7 is what number? 1, okay? 7 divided by 7 is 1. So we're really multiplying by, look at my hands, look at my hands, look at my hands. 1. We're multiplying by 1. Okay, we're just making it look different. Okay, so A is equal to 2/7. That one didn't change. Minus doesn't change. 1 times 7 is 1 times 7 is 7. 1 times 7 is 7. So A is equal to 2/7 minus 7/7. Okay, once we have common denominators, our denominator stays the same. 2 minus 7 is what? 5, but it's a negative 5 as Presley stated, okay? We can do 7 minus 2, but we get a 5, but the 7 was bigger, so that's negative. A is equal to -5/7, okay? Questions on that? Okay. Do not cross out 4 and 5. Do not, I repeat, not cross out 4 and 5. Okay, we're going to get back to that. Remember, this is not work for number 4. Chase said that this isn't work on number 4. This is work we just did in an empty space for now, okay? I realize that would be confusing coming to get off that, okay? So do not cross out 4 and 5. We will get to those next class, so we will have homework now. We got far enough to do that. Woo-hoo! Bless you and bless the rain down in Africa, lest we forget. And the souls, I suppose.
Oh, look at this. Does anyone say that, or is it just me that says that?
It's one time to say.
Bless you, bless the rain down in Africa, lest we forget. Some people have started saying it because of me.
No, but like, is there
I
like
say it
a
like
thing
without
that you do, like
noticing,
that's just you?
That's just me.
Oh.
I'm just weird. I'm just a trendsetter. Mr. Kessel is a real trendsetter.
No,
Oh,
you're
yeah,
not.
okay.
I mean, he obviously is if we start doing it.
Boom.
I
Okay.
say so.
On the front, there's a front and a back. Okay, on the front, I want you to do all of them. On the back, I want you to do just the evens. Now heads up, on the even side on the back, is that the right side or the left side?
Right.
The right side. Whoa, it's nice and divided into sides for us, okay? Aw, okay. So on the front, I want you to do all of them. On the back, I want you to do just the evens. Questions on that? When is this going to be due?
Next class.
Next class, which is Thursday. Okay?
Thursday. Oh my gosh, it's Thursday.
Yes.
I thought today was Monday. It's not.
Okay. Questions?
What's the date?
Okay. Today is the 10th all day long.
Is this first or second hour?
This is our second hour.
Oh my
This is
gosh.
first block, but it's second hour.
If you add 10 and 9 together,
It's
it equals
even.
19.
It goes 2, 4, 6.
Oh my God.
It's not.
It's an even day. Oh, it's an odd day.
The day.
Whoa!
It's an
It's
odd
an odd
day,
day.
but it's the 10th.
This is the first period and first block. Ooh. No wonder you're giving me a weird look, Victoria.
I was just confused.
Yeah. No. Ooh. You guys can listen to me. There's only about 4 minutes left, though. So I don't know how long it'll take to pick a song. Okay, I'm gonna play a song real quick as well.
Yeah.
Play.
Like Rockstar.
I'm gonna go ahead and guess it's not appropriate. It's by Kendrick.
That song's good.
I'm still gonna guess it's not.